Okay, I hope am I audible? आवाज ऐकू येतं? Screen. Okay, let's start with the next point now. In previous chapter lecture, we have started with the I think static series compensators. In that, we have already seen the basic objectives of series compensators, right? Objective क्या होता है? Just by cancelling the part of a reactance or impedance of a transmission line, we are trying to improve the net transmittable power, that is capital P. Because we know that equation capital P is equal to Vs into Vr upon x sin del, right? That divided by x, from that we can come to know that P and x both are inversely proportional. So if somehow if we decrease the value of x, obviously we can increase the transmittable power through the same transmission line just by using some compensator, correct? So how to cancel out that net impedance of the transmission line? Just by adding series capacitor into that transmission line, right? Now, for short transmission line, it is okay to connect a series capacitor, but for a medium or a long transmission line, you need to connect one shunt inductance also. Because as we are cancel outing the net impedance of the transmission line, means I mean we are cancelling the net reactive or inductive reactance of the transmission line. Means what? Now जर समजा as capacitor, connected capacitor as well as the formed capacitor between line and ground, both will now try to generate the reactive power and inject into the transmission line. ते जर त्याला कंझ्युम करणारा कोण आहे. So that's why we are going to connect one shunt inductance for only long or a medium transmission line. In that case, ते कशासाठी वापरतो? Just to absorb that their excessive reactive power, right? Now there are different types of static series compensator. One is based on whether you are physically using inductor or capacitor or not, right? Means if you are using the physically capacitor, means you are connecting capacitor into the transmission line. That is a type of variable impedance type series compensator. Okay. Again, in that we have different type. We'll see that initially. Then later we'll go with the converter based type static series compensators. Okay. In that we are not going to use any physical capacitor. ठीक है. आता हे जे काय आहे point number 6.2 variable impedance type series compensator. Remember, we are trying to cancel out the inductive reactance of the transmission line. Now cancel करण्यासाठी आपण काय करावं लागेल? Connect only capacitor, right? म्हणजे याचा अर्थ आता ह्यापुढे मी जे काही बोलेन, we are connecting a compensator, we are connecting a compensator. In that case, I'm connecting one series capacitor into the transmission line. Series capacitor, just to reduce the value of x. And you all know that degree of series compensation given by xc upon x. Last time lecture मध्ये आपण बघितलं. We have replaced that xc upon x by k. जसं k वाढवत जाल तसं x कमी होईल, जसं x कमी होईल तसं p वाढत जाईल. We have seen that Friedel curve also, right? If k is equal to 0, it means what? There is no any compensator connected. Okay. Now, just as a reactive shunt compensation, जसं तिकडे इंडक्टर किंवा कॅपॅसिटर शंट फॅशनमध्ये कनेक्ट करतो. आता इथे तुम्ही फक्त कॅपॅसिटर कनेक्ट करता in a series with the transmission line. So just as in reactive shunt compensation, variable impedance type series compensators are composed of thyristor switch or controlled. थायरिस्टर इथे दोन्ही बोललेलं आहे. स्विच्ड पण आहे, कंट्रोल्ड पण आहे. कॅपॅसिटर्स और थायरिस्टर कंट्रोल्ड रिएक्टर्स विथ अ फिक्स कॅपॅसिटर्स. बघा म्हणजे काय म्हणतो हा, सी काय म्हणतो बघा. The series compensator are composed of First one is a thyristor switched capacitor, thyristor switched capacitor, and then thyristor controlled capacitor. दोन डिवाइस आले किंवा thyristor controlled reactors with fixed capacitor. Capacitor is connected with in a fixed fashion. ठीक है. So यातलेच बघूया. First one is a GTO thyristor controlled series capacitor. ठीक है. Means here you are using GTO, gate turn off device, to make honor of the series capacitor. ठीक है. That's why its name is a GCSC, GTO based or a GTO controlled series capacitor. ठीक आहे. ऑब्वियसली म्हणजे एक पिक्चर तुमच्या समोरच येईल. कपॅसिटर इज कनेक्टेड इन सिरीज फॅशन. नेमकं ते ट्रान्समिशन लाईनमध्ये ठेवायचं की नाही ठेवायचं, हू विल डिसाइड दॅट? GTO विल डिसाइड दॅट, राईट. यू कॅन सी इट्स डायग्राम. Here is the line. Yeah, हा line आहे समजा. In that I am connecting one capacitor. That fine. आता हे काय स्विच वगैरे वापरलं नाही तर ऑब्वियसली यू कॅन सी capacitor is connected permanently, right? Now instead of this capacitor, what if I connect one mechanical switch? Initially I'll consider mechanical switch. I have connected that mechanical switch in parallel with the capacitor. Okay, in parallel. If suppose if this switch is in an off position, what will happen? This entire capacitor C will be connected in series with the transmission line. Current हा off आहे, right? Circuit इकडनं तर complete नाही होणार. What if the switch is closed? As you all know that current always takes a lowest resistance path flow through this path. I mean it will bypass the capacitor. Correct? In that case, capacitor is not connected in series with them. It's fully off by capacitor. Getting me? Now instead of using mechanical switch, what I'll do, I will now use GTO or thyristors which are connected in an angle fashion. Okay, one will work in a positive half cycle or second will work in a negative half cycle. Okay, now if I am able to control the value of alpha of these thyristors, obviously I can control the amount of reactance connected in series with the transmission line, right? Now if suppose if the firing angle of these two thyristor or the GTO is exactly 0 degree, means what? These two thyristor are working as an open circuit, fully off. Correct? As so net entire full capacitive reactance is connected in series with the transmission line, right? Now similarly, if suppose firing angle is exactly 90 degree, means this is working as a closed switch, it will bypass the capacitor. Now, in between 0 to 90 degree, that is controlled capacitor, right? Zero conduction, full conduction, partial conduction. ठीक आहे. आधी बघूया पार्शियल कंडक्शन पॉसिबल आहे की नाही, बिकॉज दिस इज कपॅसिटर. कारण मागच्या ह्याच्यामध्ये बोललो तुम्ही while teaching you the shunt compensator that you cannot switch on the capacitor on TCC हा डिव्हाइस नव्हता, थायरिस्टर कंट्रोल कॅपॅसिटर, बरोबर. दिस इज इन केस ऑफ अ शंट फॅशन. सिरीज फंडामेंटल ॲप्लिकेबल आहे की ते बघूया. Okay, हे diagram कळलं hope so. So instead of thyristor, you can use GTO also. In that case, it is called as GCSC. GTO controlled series capacitor. Right? An elementary GTO thyristor control series capacitor proposed by Carady, scientist होता, in 1992 is shown in figure 6.8. This one. Okay? Hello? Huh? Screen? Okay. काय काय यूट्यूब बंद झालं सुरू आहे काय येतं एरर काय माझ्याकडे तर लाईव्ह सुरू आहे सुरू आहे यूट्यूबला येतच नाही का लिंक चुकीची आली का हा वन वॉचिंग ना मीच बघतोय नंतर बघतील नंतर लिंक पाठवतो I can see that so obviously the current will flow through this capacitor, right? Let that current value is I. When this current flows through this capacitor, whose value is like XC. So according to Ohm's law, some voltage will get dropped across this capacitor is like VC. Okay. It consists of this GCSC consists of a fixed capacitor, a capacitor in parallel with a GTO or any equivalent switch. You can use thyristor also. That is the capability to turn on and off depend upon the firing angle that is on the command. Okay? हे वेवफॉर्म थोड़ा सांगतो. This capacitor scheme is interesting in that it is the perfect combination of well-established TCR, thyristor controlled reactor, having a unique capability of directly varying the capacitor voltage by delay angle. Got that? What he's saying, you can directly vary the voltage across capacitor. Capacitor is a VC, which is given by I into XC. Right? Now XC कैसे control करू शकता? By controlling the firing angle of this switch. That's what he's saying. Just by controlling the angle, firing angle, alpha you can able to control XC. XC control करता है ह्याचाच अर्थ दूसरा अर्थ you can vary the voltage across capacitor. Right? Apart from the theoretical interest, this technique, as it will be seen, has some operational merits and it may be incorporated into some series compensator scheme in the future, particularly when larger GTO thyristor become available. The objective of the GCSC scheme is to control the AC voltage across the capacitor. Obviously, correct? At a given line current I is equal to VC upon XC. When the GTO wall SW is closed, means it is short circuited. Huh? Huh. ह्याच्यावरती गुगल मीटवरती पण आता त्याला मी काय मी तर तुमच्या समोर बसलो आहे पण तुम्ही जे नेट वापरता तेच मी वापरतो ना हम्म. दोन तीन मिनिटं असं त्या तुमच्याकडे वळू का मी? नाही पण डिले आहे, मग मी बोलणं वेगळं असं पण होईल ना, तुम्ही समोर बसला. एक काम करा, ह्याला टेबललाच असं वळू आहे ना, नीट जाईल ना, नीट जाईल. नीट आहे. ओके. ऑनलाईन स्टुडंट्स, अक्षय, आवाज ऐकू येत आहे? आणि स्क्रीन just comment in the chat box, screen, and what about audio? Akshay, so screen is visible. Okay. कुठे होतो आपण? See, when the wall is open, I mean he is saying when this wall is closed होता ना आधी. When the GTO wall SW is closed, means your current is taking this path. Means what? It is bypassing the capacitors, right? The voltage across capacitor will always be zero, current is bypassing the capacitor. Now, and when the wall, the condition महत्वाचा आहे. Point number one, when SW is closed, based on this I am going to draw the comma. When SW is closed, the voltage across capacitor is zero. Right? Now, आता कोणी सांगू शकाल का? When SW is closed, means the firing angle is 90 degree. Alpha is equal to 90 degree. Right? Point number two, when SW is open, fully open I am saying, in that case firing angle is obviously 0 degree and voltage across capacitor will be at its maximum value, right? Voltage across capacitor is given by I into XC, no? I into XC. A capital I card like a small I and value. Instead I am talking about instantaneous values, right? And when the wall is open, the capacitor voltage is at its maximum. Okay. Now for controlling the capacitor voltage, if you want to vary the capacitor voltage, you need to control the firing angle between 0 to 90 degree. The closing and opening of the wall is carried out in each half cycle in a synchronism with the AC system. The GTO wall is stipulated to close automatically whenever the capacitor voltage across 0. बघा काय म्हणतोय, whenever the capacitor voltage crosses the 0, when capacitor voltage crosses 0, the waveform GTO will automatically get closed. असं केलेलं असतं ते. GTO closed means what? असं. Okay, it is bypassing the capacitor. आधी हे वेवफॉर्म बघूया आपण. See, if I want to draw the voltage as well as current waveform, that is the voltage across this capacitor is like VC. Obviously, as it is a capacitive reactance, pure capacitive reactance, current will lead this voltage by exactly 9. Okay. Now let when alpha is a 0 degree, the alpha is a 0 degree, VC is at its maximum or normal value, which is given by XC. Take out. This is what VC when alpha equal to 0. Right? Now in that case, where will be current? Current will lead this voltage by exactly 90 degree. Will lead means what? It will start from a 90 degree. Right? So now. This is what the current. See. This is what the voltage across capacitor when alpha equal to 0, and in that case current is by exactly 90 degree. Now what if firing angle is exactly 0? Sorry, it's exactly 90 degree. What if firing angle is exactly 90 degree means what? BC is a 0. तेव्हा VC किती असेल? Straight line 0. Correct? Now in between that, let my firing angle is 45 degree. 0 and 90. In that case, VC will be not exactly half, but it will get reduced. But obviously, याच्यापेक्षा तो कमी असतो. So for any angle between 0 to 90 degree, you may get VC. Correct? You can see here. This is what's shown here. For any angle, that firing angle is good. Sorry, मी हे विसरलो. याला undo करता हूँ. If a firing angle is like 45 degrees, so obviously it will delay by 45 degrees, not from origin. इतना सा. And this is what you call it as a firing angle, 45 degrees. Correct? If the firing angle is 45 degrees, then what is the conduction angle? If firing angle is 45 degree, बघा ना इकडनं 45 जाईल, इकडनं 45 जाईल. 180 मधून 90 होता खरा, 90 degree will be the conduction. Right? इथे VC exactly 0 दाखवलं नाही का? नाही. Any angle. For controlling the capacitor voltage, the closing and opening of the valve is carried out in each half cycle. Okay, हे झालेलं आहे. Now the GTO valve is stipulated to close automatically whenever the capacitor voltage crosses 0. When capacitor voltage cross 0, GT will automatically get closed. However, बघा इथे जेव्हा capacitor voltage cross the 0, इथे 0 क्रॉस करतो capacitor voltage किंवा इथे firing angle is alpha. What about the GTO? GTO get close. GTO close होतोय. मग मला सांगाल का GTO च्या अक्रॉसचा व्होल्टेज किती असेल? zero. बरोबर ना? When capacity बघा, sequence बघा. When capacitor voltage reaches to or